For question 88, we've got a mass that's originally at rest. So there's some object, mass, V0 equals 0. And then an impulse acts on it and it takes off. We want to know about the change in kinetic energy. So first of all, since we're looking for change in kinetic energy, let's spell out change in kinetic energy. Change in kinetic energy is the final kinetic energy minus the initial kinetic energy. Now the initial kinetic energy, since it's at rest, is 0. So the change in kinetic energy is the kinetic energy. So that's the first thing to realize. So then how do we find the kinetic energy? Well, kinetic energy is 1/2 mv squared. Now, if we look at all our choices, we have I, impulse, and mass. What is notably missing is the V. So we have our four-way equivalents. J equals F net T equals delta P equals M delta V. And so we have mv like this, and we have the impulse J. So the impulse, which we're going to use I, because that's what's in the answers, is m delta V, and delta V is V minus V0. Well, V0 is 0. So the impulse is mv. Now to get rid of the V, we could solve this equation for V, and we get I over m. So now we have 1/2 m times the quantity I over m squared, which is 1/2 m I squared over m squared. Squared goes away, and that goes away, and that leaves us with 1/2 I squared over m. And we can see that is choice B. So using simply using the algebra, we can find the answer to this question. We could also have used dimensional analysis. And so first, let's find out, we're looking for one of these that has the same units as energy. So let's find out the units of energy. And the units of energy, constant disappears, and we have kilogram times the quantity meters per second squared. So that is going to be kilogram meter squared per second squared as the units of kinetic energy. So which of these has the same units? Well, let's take I squared m. Well, I squared, I has the same units of momentum, which are kilogram meters per second. So that entire quantity squared times m. Well, that gives us kilogram squared, meters squared per second squared times meters, which is kilograms squared, meters cubed per second squared. So clearly that's not the units. And now we can look at the units of I squared. We'll go jump to D, and we have 2I squared m, and I squared is kilogram meters per second, quantity squared, times m. And notice, since this is I squared m and this is I squared m, it will have the same units. So this will also be kilograms squared, meters cubed per second squared. Now, if we notice B and C, they have the same quantity, so they will also have the same units. So by using dimensional analysis, we can eliminate choice A and choice D, but choice B and C have the same units. By algebra, we bring it down and narrow it to B.